Hi everyone, welcome back for part 4, History of Civil Engineering, part 4 of the Egyptian Engineering. I'm just going to carry on from where I finished just a minute ago, which was on this page. So here we go. All the streets were set out at right angles with each other, and more than a third of the area comprised within the walls was devoted to public purposes. Every private dwelling has its reservoir of water provided for it, which was supplied by subterranean conduits of the Nile, all built of stone, with flat terraces at the top, which answered for their covering, timber being sparingly used in their construction. The cisterns and conduits were lined with fine cement, which remains perfect at the present day. To render the harbour approachable at all times, a lighthouse was built on a rock, some distance from the eastern extremity of the Isle of Pharos, which was long considerable one of the wonders of the world, and which was given the name to all others. A mole united the rock with the mainland, and Sostratus of Cnidos, who was so esteemed by Ptolemy Philadelphus that he was surnamed the Friend of Kings, was the engineer employed for its construction. This Pharos was in height 450 feet, and could be seen at a distance of 100 miles. It was formed of several stories, decreasing in dimension towards the top, where fires were leaned in a species of lantern. The ground floor was hexagonal, the sides alternately concave and convex, each stadium in length. The second and third stories were of the same form. The fourth was square, with the round tower at each angle, and the fifth circular continued to the top, to which a winding staircase conducted. The hull, exquisitely wrought in stone, was surrounded entirely by a sea wall. On entering the harbour, this wonderful structure was on the right hand, and a promontory of Lycaeus to the left, where was placed the palace or royal residence, near which was the island called Antirrhodus, which contained a small harbour devoted entirely to the reception of royal vessels. The ancient causeway now forms the site of the part of the modern town, and is in length about 4,000 feet, on the easternmost side of the great harbour, and on the western of that Eunostus, or as it is now called, the ancient port. Here is a basin or Kibotos, which by means of a canal communicates with the lake Marotis, the dimensions of which Strabo says is 300 stadia in length, 100 in breadth, and that it contained 8 islands. Alexandria was second in importance only to Rome itself. Its circumference was 15 miles, and its population estimated at 300,000 free inhabitants, beside an equal number of slaves and dependents. In the streets, idleness was unknown. Some were employed in blowing glass, in weaving linen, and manufacturing papyrus. When Caesar arrived at Alexandria, he sent to Rhodes, Syria, and Sicilia for his fleet, and upon reconnoitring the town, he found all the avenues and passes shut up by a triple wall, 40 feet in height, built with square stone. The lower portions of the city were defended by lofty towers 10 stories in height. There were many timber structures of the same height, movable on wheels, which could be drawn by horses. We also learnt that he found Alexandria most hollow underneath, from the many aqueducts what flourished allowed to throw down the earthly manna and become perfectly clear. Ganymede, the Alexandrian general, to deprive the Romans of a supply of that part of the city of which they had taken possession, stopped the current through these subterraneous passages, which led from the Nile, and turned salt water into them, which caused a great wonder as well as inconvenience to the Romans. Caesar, on the discovery, ordered his soldiers to find water by digging wells, telling them that on all seacoasts fresh springs abounded, and that the alacrity used was so great that they arrived at fresh water in abundance the first night after digging commenced. Smelting and refining metals. The Egyptians began this process by pounding their golden ore and reducing it to very small grains. Then they put it into a mill and ground it into powder, after which it was spread on boards slightly inclined. Water was then made to flow over it, which carried away the earthy particles. After the watering had been frequently repeated, it was rubbed by the workmen for some time between their hands and wiped with small sponges until nothing was left but the gold. It was then put into earthen pots and mixed with certain proportions of lead, salt, tin, barley meal, and after this it was poured into other vessels, which were luted with great care and placed in a refining furnace for 5 days and nights. These were then taken out and suffered to cool, and when the gold was found to be quite pure, they do not appear, according to Pliny, to have used quicksilver for the refining of either gold or silver. Lead was the menstruum, and by frequent meltings the pure metal was obtained. The great quantity of gold used by this people convinces us that the art of mining, smelting, and refining that metal was well understood. Forging metals was known in Egypt at the earliest time. Most of the arms, tools, and husbandry of the mechanical arts were usually made of copper or brass, though in time of Moses we find iron well known. He describes its hardness, speaks of mines, and mentions the iron furnaces and tools for cutting stone made of iron. Hydraulics. In the school of Alexandria, which flourished under the patronage of Ptolemies, the first machines for the purpose of raising water seem to have been invented. After Hippocrates had constructed tables which showed the exact motion of the sun, clepsydrae or water dials were brought in with great perfection by Scipio Nasica, the cousin of Scipio Africanus, who about 200 years before Christ introduced them into Rome. Ctesibus, who flourished in the reign of Ptolemy Ciscus and 120 years before Christ, brought these machines in with very general use and invented the hydraulic organ, which was operated upon by air and water. In a clepsydra he introduced, probably for the first time, toothed wheels. This instrument for the measurement of hours was a cylinder resting upon a pedestal. 2 figures were placed upon the latter, one of which dropped water into its eyes, from its eyes, whilst the other pointed with a wand its axis once a year. Whilst the other pointed with a wand to the hour marked on the vertical line drawn upon the cylinder. The cylinder turned on its axis once a year, and on it were drawn curved lines which exhibited the inequality of the hours of different days by their being marked at unequal distances. The manner of working this machine was to allow the water to rise through a tube which passed through one figure, was discharged by the eyes into a reservoir M, from which it passes by a hole near M into a pipe B, C, D. In this pipe was a piece of wood. Water hydraulics, floated upon the surface, and by its ascent, as the pipe filled, it raised the small pillar CD, on which the other figure rested, and as the float rose in the pipe, and a wand was made to point to different hours. Every 24 hours the vessel became filled, as did the inverted siphon which communicated with it. The water was then drawn off by the siphon and falling into its descent into buckets at the wheel below, and put into motion. The wheel had 6 buckets, and therefore made 1 revolution every 6 days. Its axis carried a pinion of 6 teeth, working on another wheel of 60 teeth. This also carried another pinion of 10 teeth, and they drove the wheel 61 teeth, which by turned its axis turned the pillar once every 366 days. So the pillar was spinning annually to move water. These machines indicate considerably hydrodynamical knowledge and derive their origin from the previous discoveries of Archimedes. Another Elepsidra received the water in a reservoir, which is always kept full, descended by a pipe into a hole formed of a great drum. This hole corresponded to one of the openings of the groove round the circumference to a small drum. The apertures of the groove in the small drum were of different sizes to admit different quantities of water, according to the length of day, and the proper aperture of the given day was found by placing the index opposite the sun's place at the zodiac, shown by N. The index O being used at night hours. The water which descended through the openings in the small drum was conveyed by the pipe F through the aperture to G, which contained reservoir H. As the water rose in the reservoir, in the inverted vessels suspended by the chain, which passed around the axis R and balanced by the counterweight, ascended and moved the hour hand, which pointed the dial plate. Incredible. Hero, the disciple of Ctesibius, wrote a treatise on mechanics whereon was described at length the various mechanical powers which are all reduced to the lever. He left also another work called Spiritalia, in which is an account of the forcing pump, which raises water by the elasticity of the air. It was probably suggested by the Egyptian Noria, a contrivance in which a number of earthen pots were attached to the periphery of a wheel for the same purpose. The Great Wall of crude brick, built by Sesostris on the eastern side of Egypt to defend it against the eruptions of the Syrians and Arabians, extended from Pelusium along the edge of the desert by Heliopolis for 1,500 stadia, or about 187 Roman miles. Amasis, who was a great promoter of the arts, erected at Sais a magnificent propylaeum in honour of Minerva, where stones of prodigious magnitude were used for construction. Herodotus says that the stones, of amazing thickness, were brought from the quarries of Memphis and part of the city of Elephantine, which is distant from Sais about 25 days' journey. But that, in his opinion, the work most to be admired was the edifices which Amasis brought from the Elephantine, constructed of one entire stone. To transport this, 2,000 men, all of whom were selected from the sailors, were employed for a period of 3 years. The length of this structure on the outside was 21 cubits, its width 14, and its height 8. Its length inside was 22 cubits and 20 digits, 12 cubits wide and 5 high. It was placed at the entrance of the temple, and the reason assigned for this being carried was no further than the architecture, in consequence of its continual fatigue, was heard to sire by Amasis, who, constructing it into an evil omen, obliged them to desist. Some affirm, however, that one of these employed to move it by the levers was crushed, for which reason it was moved no further. This resembled probably by the red granite monolith at Tel et Mai, which measures in height 21 feet 9 inches, 13 feet in breadth, and 11 feet 7 inches in depth outside, and 10 feet 9 inches, 8 feet and 8 feet and 8 feet 3 inches inside. At Memphis, a colossal recumbent figure, 75 feet long, was, according to Strabo, placed before the dromos of his temple by his king, as were also masses of granite 20 feet in height. At Thebes and other places, as well as the quarries in Syene, are numerous inscriptions which indicate the removal of granite blocks of enormous weight for the decoration of edifices raised by this prince. Quarries of Egypt. The granite was obtained by Zen, which is a district reaching from the island of Philae along the whole line of the cataracts. The finest quality is obtained on the banks of the river. The beautiful pink or rose-coloured granite. This syenite of the ancients is very hard and composed of large crystals, which receive its excellent polish. 2/3 of the mass is rose-coloured feldspar. Sparkling mica and glassy quartz fill up the intermediate spaces, with the hornblende occasionally. Pliny sometimes designates obelisks made of this granite as Fabaceous lapis, because it came from the region between Thebes and Syene. Another granite, more resembling that of the ordinary kind, is found contiguous to it, with particles occasionally much coarser or finer. To these may be added the finer grained granite, with the grey coloured feldspar, black and white granite, which has the white feldspar, and black flakes of mica and oriental basalt, a very dark kind which is owing to the abundance of mica. The sandstone quarries of Hadshar Selsalah furnish the chief part of the building stone for the temples. They are situated in the sandstone district, and according to some, the stone resembles the Grès de Fontainebleau, which is first taken from the quarry. It is easily worked and may be obtained in lengths of 30 feet or more. We find stone quarries of great extent on the borders of the valley of the Nile. Limestone was generally employed in all the early buildings, and quarries from whence large quantities were taken may be seen at the Masara, where the tablets remaining, cut in the time of Ames or Amasis, the leader of the 18th dynasty, who ascended the throne about 1500 years before Christ. And from these quarries all the compact magnesian limestone used in the construction of the pyramids of Giza was taken. There are other quarries at Tena, on the point of a hill, where there is a thin deposit of crystallised carbonate of lime. Numerous nautili are found embedded in the limestone, some of which are more than 6 inches in diameter. In examining these excavations, we obtained some knowledge of the early Egyptian practice of detaching masses of stone, and also a valuable lesson in the saving both material and labour. To the Egyptians, the difficulty of constructing a pyramid was scarcely more than the removal of stone from the quarry, and building it up in the manner in which it lay previous to its being detached from its original bed. The only difference was that the top stones of the quarry became the foundation stones of the pyramid. They were taken away in layers in the same thickness and built on courses. As the rock proceeded, the quarry might represent many steps from the bottom to top as the pyramid. The stone was sure to lie on the right way of its bed, and it would be scarcely necessary to mark an oblong stone. After it was detached, its depth being uniform with others would indicate sufficiently its true position. The manner in which the quarry was worked is deserving of our attention. It was commenced by levelling the surface of the rock and marking out the square area of sufficient dimensions to afford the quantity of stone required. Around this was cut a deep trench at parallel distances 7 or 8 feet apart, according to the size of the stones. The other parallel trenches were made, and then similar lines of right angles dividing the whole into many squares. After this, the blocks were cut into their required thickness. Layer after layer was thus removed according to the depth of the quarry, or as long as it yielded good stone. At other times, after the square was marked out on the top of the intended quarry, which was usually selected on the side of a hill, or where the face was perpendicular to the plain below, and a horizontal trench was driven through the middle of the square, then the masses of rock were detached on each side of this first groove. and as each layer was removed, the new trenches were cut, until the whole assumed the character of a series of steps on each side of the centre, which rose from the bottom to the top of the quarry, and resembling the form of a pyramid. The same machinery which lifted the stones from their beds or steps answered to elevate them in their new position. Limestone continued in use for many years, after which fine sandstone was employed, which was discovered to be far greater durability. The qualities of Sicilus are extensive and situated between Edfu and Gebel Silsileh. From them most of the sandstone was obtained, which was used in the Egyptian temples and other public buildings. Tora and Masara stone quarries. The Troisi Lapidus Mons. The Pasha has here a railroad for conveying stone to the river, which is then transported to Cairo, a distance of between 6 and 7 miles. These quarries supplied the stone to many of the pyramids and temples, and afforded employment to a vast number of men. On a range of sandy hills upon the edge of the desert, which extends the whole length of the quarries, was discovered upwards of 150 sarcophagi made of compact limestone, which no doubt contained the bodies of those employed in extracting the stone. One sarcophagus was found in earthenware in a single piece, having a lid of the same material. Many skeletons without coffins or sarcophagi were found. These bodies appear to have been interred into clothes or wrappers of coarse woolen cloth. There are also heads of oxen with the horns and several hundred coffins, and many tombs covered with the slabs of calcareous stone, where the bodies are preserved in bitumen and the coffin not made use of. Among the several articles within them was the model of the pyramid in calcareous stone, 26.5 inches square at the base, and at the same height. It was also a piece of bronze, which resembled the heads of hatchets. There were several inscriptions to local divinities, put up when the fresh works were commenced on the quarries. The earliest supposed to refer to the reign of Amoneme IV, another to the time of Necho. At the Torah quarry is a tablet dedicated to the son of the sun, Amonem, believed to be Phtar. In the rampart of the south and of Anubis, the opening of the quarries is also alluded to, and orders given to the cutting a good of white stone, which is calcareous for the temples of the gods. Some of the tablets are in the form of a propylaeon, having hieroglyphic inscription on the lintels. One refers to Ammonophis II, and has been interpreted as commanding the opening of the quarries to draw the good and white stone for the repairs of the temples for a series of years. The whole apparently being under the director of the superintendents of the military chief. Attached to the heights of the king for his knowledge and skill in architecture, one who had adorned the temples of Mesopotamia and in Libya, and was put over the bearers of Egypt. Of all the gods of the north and of the south, Libya and Mesopotamia are said by M. Champollion to have been conquered by Amenoph II, or by his predecessors. These tablets are signed by the royal scribe Saf, and the architect or surveyor engaged to design the public buildings. Another of these tablets refers to Amenoph III, or Memnon, who is seen offering a symbolic eye in a basket which he holds in both hands. In the hieroglyphic inscription, he is termed the establisher of the houses of stone, and he orders the opening of the quarries to procure good and white stone. In the Masara quarries, which were worked from north to south, the tablets referring to Amasis Psammetichus II, and to some of the Ptolemies, beneath one of the hieroglyphic inscriptions of Amasis, his wife Nofrira. It represented a block of stone drawn by 6 oxen on a sledge, tended by 3 men. On the interpretation, the writing is that the quarries were opened in the 43rd year of Amonem, were again worked in the building of the 22nd of Amasis, when the temples of Ptah and Ammon in Thebes were built. The kings of the 16th and 17th dynasties, at that time having their capital at Abydos. These tablets allude to Thebes, which superseded Memphis in the capital after the kings of Egypt had grown more powerful. There are other tablets at the time of Ptolemy Philadelphus. The quarries and silsilis at a vast extent, and masses of dimensions might be hewn from them. When a quarry was opened, if the stone could not be drawn from the perpendicular face, they drove a horizontal shaft into it, of which a level which could afford the quarry they required. They then worked the massive horizontal steps, which they made the necessary depth and width. In the quarries of considerable extent, they left pillars at intervals to support the superincumbent earth. The stone, after it was quarried, was placed on sledges and drawn by men or by oxen. Inclined planes were often used to facilitate its movement. Many instances may be found of a private mark of the stones, which indicated the number drawn by the slaves employed for this purpose. In a grotto between Atino and El Bersha is a painting where a colossal statue is moved by a number of men dragging ropes. This painting is very early production and shows the method employed at the time for moving great masses. 172 men in 4 rows of 43 each pull the ropes attached to the front of the sledge, on which the statue's seated figure is placed. On the knees of the figure stands a man, directing them to move together or to pull uniformly. The statue is secured to the wooden sledge by ropes. These are doubled and further tightened by the insertion of long pegs, which are twisted round and made perfectly secure. Some of the obelisks brought from the quarries of Syene and Thebes Heliopolis, a distance of 800 miles, are of a single stone, varying in size from 70 to 93 feet in length, of the largest and great temple in Karnak, and has been calculated to weigh upwards of 297 tons, and must have been brought about 138 miles. In the plain of Korner is about 2 colossi of Amunoph III, each of a single block and 47 feet in height, containing 11,500 cubic feet. At the Menomium is another of Rameses II, which, when entire, weighed 887 tons, and which, from the nature of the stone, was probably brought 138 miles. The shrine of the goddess Latona, at the Sebennytic mouth of the Nile, in the large city of Boutos, astonished Herodotus, who says that it was 40 cubits or 60 feet in height, breadth and thickness, and was cut out of one single stone. And after it was hollowed out, a stone 4 cubits in thickness formed its roof. The internal dimensions and thickness of the walls are not given, but if of granite, as those monolithic temples were, the weight must have been some thousands of tons. Obelisks in their removal require skill and strength, but to elevate them, considerable knowledge of mechanics must have been brought into application. They are often raised at a great height and placed with the utmost precision in a perfectly perpendicular position. Some very large blocks of sandstone, and particularly one which forms the lintel to the gateway leading to the grand hall of the Karnak, is 5 feet 2 inches square and 40 feet 10 inches in length, and it seems difficult to understand by what means it was lifted to its present position. But the Egyptians were learned by the mechanical arts, so they were evidently as capable of raising weights as they are at the present day. In one of the quarries at Syene, there remains a broken obelisk, where it was separated from the rock, and the depth of the quarry is so small and the entrance so narrow that the stone could not be turned around. So it must have been lifted up from its bed, where the case and all the shafts hewn out of this quarry. One of these obelisks, 99 feet in height, and on which 20,000 workmen were employed, was raised by Ramesses. Pliny mentions the method usually adopted to float these masses from one quarry's. The method used was to float them from quarries down the river. 2 flat-bottomed boats were lashed together, side by side, and then had a trench cut out them into the Nile. They were laden at first, with much ballast and equal to the weight of the obelisk to be transported. When they were introduced under the weight, the ballast was taken out, and the boat rising, they were lightened, bore off the obelisk in lieu of it. These large masses of granite may have been detached from their beds in the same manner, as is still practised in the East, where, after cutting the groove into the stone throughout the entire length, a fire is made upon the rock, which then sufficiently heated, burning the ashes are swept suddenly off, and water as cold as it can be obtained is then poured simultaneously by a number of individuals into the groove, and a clean fracture takes place throughout the whole line. Wow, that's quite interesting. Right, so I don't have much time left. There's still 3 pages. I'll see if I can just let you, rather than reading it, if you want to pause it and read that. And I'll do that for the rest of this chapter, which is about a page. And this will be it for Egyptian engineering. So yeah, next video will be going on to Grecian engineering. Sorry about my reading. I'll try and get more practice in off the recording. But yeah, there was quite a bit of information in there. It was quite interesting, so I'm kind of hoping the same for the next chapter as well. Anyway, I hope you enjoyed. God bless.